All right, this is Mr. Wyrick, and I'm here to take you through the Unit 6B test review as much as I can without the calculator. I'll give you the guidance that you need for the calculator parts. So number one, we did this one in class, talking about domain and range of the graph. Remember, domain is x, goes left to right. Range is y, goes bottom to top. The domain of this one, with it being the graph, having the arrows on both sides, is going to be all real numbers, okay? Everything. It doesn't stop going in either direction. The range, because this is my asymptote, we get closer and closer to zero. We never touch it. Its y is greater than zero. On this one, when we find this exponential function, this is going to be in the form y is equal to a times b to the x power. This one, I don't even remember everything about it. I remember this is like 137,000 and some change. So that means this is y is equal to 137,000, whatever it was, times. Now this is going to be probably like a 10-15% growth. So that's 1.15 or something like that to the x power. The important thing to remember on this is to go through data and statistics, listen spreadsheets, enter the whole thing in there and go through it. This is growth, and remember, it's how far it is from 1. So we ignore this 1. We go over 2 decimal places. That's like 15%. Again, you can check the key online to find that one. On this one, a toy is made up of cylindrical rings. It's talking about each one is 90% of the diameter of that previous one. If the base is 7 inches, that's my initial value of 7. And each ring going up from there is 90% of that, which when we make that a decimal, that's 0.9 raised to the x power, where x is my number of the base, y equals. On this one, this is the same as the one before it. You enter it, but this one gives us the initial value. So 0.0625, and in this case, we're multiplying everything by 4 to the x. So that's a y equals. My initial value is that 0.0625. It's where we equal 0. And my growth or decay, again, this is growth. We ignore a 1 here. So 4 minus 1 is going to be 3. And then we move our decimal over 2 places to change from a decimal to a percent. That's 300% growth. On this one, based on the data in the table, what will the population be at the end of 10 months? It's doubling every single time. So this is going to be 6 times 2 to the 10th power, whatever that would be. Okay? Again, this one is on your, the key is loaded in the Google Classroom. You can take a look at it. On number 6, we did this one together in class. 789 cell phones is my initial value. They increased at 2.25%. I go over 2 decimal places, and I've got a 1 in front of it to keep it. So 1.0225 to the m power, and that's p of m, because that's the variables it's telling us to use. Remember, if it's growth, and this is growing, they're increasing, it has to be more than 1 that you are multiplying by. Number 7, the factory is making new parts. The data is collected on the number of defective. I'm just going to connect these dots down through here like this. And so it says, based on the graph, during which week were approximately 180 defective parts per 10,000 produced. Let's see, 180 would be about right there, which would be 3. The 3rd week. Okay, just complete the curve, find the information it's asking for. It's about estimation. Can you figure out what's going on? Number 8, find the exponential function. This one, remember, was 0, 400, 1, 500, and then 625. My initial value is 400. My growth is going to be 25% on that one. So that's 400 times 1.25 to the x power. On this one, the annual salary at 6.2. When I worked this one, I just went straight to the 10th year and said, how much would they be making? This is way too fast. This one's way too fast. And it's starting at 5,000. No, this is supposed to be, yeah, if it's starting at 5,000, this is the one that starts at 5,000 and actually goes up at like 6%. So that would be there. Let's see, on the back side, number 10. Based on the data, find the measurement closest to the number of square kilometers of land that will be occupied by the cane toads 50 years. So this curve is going to keep going, but the 50 is not even over here. This only goes up to 35. It's not exactly doubling. It's like a 1.3 or 1.4%. So what you're going to need to do is this going to be 36,500 times 1 point whatever my percent growth is raised to the 50th power. And that'll give you how much they're occupying based on that, okay? You can go back and you can do lists and spreadsheets with this. The answer is going to be on the Google Classroom. You can check the key. Just make sure you understand how to get that answer. The antibiotic in this one, find the value close to the amount of time needed for it to drop to 5,000. On this, you would just enter this. Don't forget, it's control and then divide to make that fraction when you're up here in the exponent. And you type this in on your graphs, pull up the table, and just scroll down to the point where you hit that 5,000. That'll give you the answer pretty quick, and it'll be an estimation. It'll be around 5,000.
Easy.
Sure, I guess that's easy. Number 12, the graph below shows the change in value of the car over several years. Based on the information in the graph, what appears to be true? 1/2 of its value every 3 years. It's tough to estimate that, so I wouldn't really go with that. 1/4 of its value every year, that could be it. Less of its value between years 9 and 10, we only lost this much. Then between 1 and 2, that's definitely true. So since this one's definitely true, that's what I'm going to do there. As time goes on, it loses less and less because it's losing the same percentage every time, okay? On this one, we did this one in class. This 10 is the $10 that we started the account. And then this 1.015 is my 1.5% interest that I am earning. Make sure you understand the difference between those two for that situation. Number 15, the domain and range on this one, because we can see it's a specific situation. It's got labels. We don't have an arrow on this side. The domain is going to be x is greater than or equal to 0 because we start over here on 0 years right at 2015. On the range, we have a definite stopping point. We have an arrow up here. So this is going to be y is greater than or equal to 250,000. Make sure you understand if the 25,000 is on the other side, that's still the same thing. If it's in words, that's still the same thing. Number 16, graph the function 1/2 times 1/3 to the x in your calculator. It's going to go like this. Does the graph have a vertical or horizontal asymptote? It's going to be horizontal at y equals 0. My y-intercept, this to the 0 power is 1, so it's my initial value, which is 1/2. The equation for the asymptote is y equals 0. When looking at the graph from left to right, does it increase or decrease? This is smaller than 1, so it's going to decrease. The amount of fertilizer on this one, left after W weeks, if it's decreasing 4%, we multiply by what we keep, which is 96%. That's to my x power, and we have 83,000 there that we're multiplying on that one. Particular type of cell doubles in number every hour. Write a function that can be used to find the number of cells at the end of h hours if there were 6. If it doubles, that's times 2 to the h. We started with 6, so that's our initial value. So y equals 6 times 2 to the h. Which dashed line below is an asymptote for the graph? It is S. It's right there at y equals 0, like it is for all of our equations on this one. Write an equation for this. Remember, our sequence was different. It was 9, 3, 1, 1/3, 1/9. We are dividing by 3 all the time, but we can't say that because we have to multiply. So this is multiplying by 1/3. And remember, this is step 1, step 2, step 3, step 4, step 5. We have to go back a step to step 0. So that's actually going to be 27 times 1/3 to the n power. Remember, if it says nth term, it's just asking you to find a number. If you have any other questions on this, stop by my desk in the morning. I'm going to wave bye to him on the camera. There you go.